Welcome to ClickMyProject.com. Our project title is JouleMR towards cost-effective and green-ever data processing frameworks. Abstract. Interest have been growing in energy management of the cluster effectively in order to reduce the energy consumption as well as the electricity cost. Renewable energy and dynamic pricing scheme in smart grids are two major emerging trends in energy markets. However, current data processing frameworks are not aware of efficiency of each joule consumed by the data centers workloads in the context of these two major trends. In fact, not all joules are equal to, in the sense that the amount of work that can be done by the joule can vary significantly in data centers. Ignoring this fact leads to significant energy waste, which by 25% of the total energy consumption in Hadoop on a Facebook production trace. According to our study, in this paper we propose JouleMR, a cost-effective and green-hour data processing framework. Especially, we investigate how to exploit such joule efficiency to maximize the benefits of renewable energy as well as dynamic pricing scheme for MapReduce framework. We develop job or task scheduling algorithm with a particular focus on the factors on joule efficiency in the data centers, including the energy efficiency of MapReduce workloads, renewable energy supply, dynamic pricing, and the battery usage. We further develop a simple yet efficient performance energy consumption model to guide our scheduling decisions. We have implemented JouleMR on the top of Hadoop. The experiment demonstrates the accuracy of our model and the effectiveness of our cost-effective and green-aware optimization outperform the state-of-art implementation over Hadoop. Let us see the flow of our project. Our JouleMR concept contains the data set of we have to load the medical data set of hundreds amount of data or 1000 amount of data. We have to take an as 1000 amount of data. So then we have to process this data into MapReduce framework. In that framework will be reduce the processing and give it to the Hadoop. So then the Hadoop will be stored that particular data set. Then we have to initialize depends on the data set according to the data center, broker, job, and VM. So these four things are first initialized. Then we have to, if the job is allocated for 5 means we have to then the processor split up the data set to 5 with the file size, file length also mentioned. So then we have to assign the job, that is the data set jobs for each VM, data center as well as the brokers. So this is done by using JouleMR with the execution time, cost and power efficient manner. So then we have to allocate the server placement strategy using the JouleMR. Then the flow time, that is the execution time of each job, cost for the relevant job, power consumption which is kilowatts per hour will be calculated. Then the graph contains the workload for each jobs, that is if the job is splitted at 4 means it will be create the 4 data sets from the single data set, and you have to calculate the file length, file size of each jobs and the workload for the each jobs. Then we have to analyze the cost of the each jobs as well as the power. Let us see the output of our project. So this is our JouleMR project which is deployed in NetBeans IDE. So we just need NetBeans IDE 8.2 version as well as the WAMP server either 2.0 or 2.5. So now I am going to run the process. So click on this index.java and click run file. It will be moved on our home page running. So this is our home page with the title. So now I'm clicking the next process. So this is for loading the data, that is our data set. So now I'm going to load the data set here. So the data set will be loaded with 1000 records, will be loaded here. Next process we have doing the map and reduce concept. For that, just click on the map and reduce. So this is automatically the background process, given that the map and reduce will be done here. So map and reduce process is done in the background process, and the reduced data set will be displayed here. Now I'm going to click this Hadoop, means it will be stored in local Hadoop server. So the data is stored in Hadoop, so that will be stored in our folder. The next process is for data center. Initialize all the four things like data center creation, PM creation, job creation, as well as the broker. So now I'm going to give 4, means it will be create 4 data centers with the host ID, servers, RAM, bandwidth. So next process is load our broker. So now I'm giving 3, means it will be correlated with the data centers. So next process is giving the virtual machines I need. So now I am going to click 3 virtual machines. So it will be create 3 virtual machine corresponding to that broker ID as well as the data centers. So next process we have to allocate job. So now I am going to click 5 jobs, means the data set will be splitted to 5. So now the job count, that is the job will be created successfully. Then I have to load the process into that particular data set. So that data set also splitted with 5 count. Then I am going to load the process. So when clicking this, means it will be create the folder like this is contains that folder. So jobs contains the, now I'm giving the 5, means it will be create 5 jobs. So the 5 jobs have the equal size. So it may be differ from the size with the properties. So byte wise it will be varied. So it is byte will be 5864 and this byte will be 5896. The byte variation is there. So the job is splitted to 5. The data set is stored in Hadoop. So Hadoop system, it will be stored in the data, so which contains thousands record. We have to split into 5 jobs now. Then I am going to run the next process. We have to load the process. Next I am going to get the number of jobs. So 5 jobs with 5 data, and the file size of each job, that is 5896 is the job with the data set file size. Then we have to allocate the VM corresponding to that job. So this is for job allocation. Now I'm going to click this job, means it will be processed in background as well as the foreground. So the job plus file size, VMware for each job. So VM0 itself allocate all the things. So we have to also calculate the power consumption and the cost and the execution time of each job in milliseconds, 9.01. And job 2 have so job 3, first job 3 is loaded because job 3 is less time, and the job 3 have less cost wise it is less cost, so it is loaded fast. So next is we have to analyze the graph of each process. So this is for cost. So each job have how much cost. So first will be the cost of 165, second will be fourth will be the cost of 400, and job 1 will be 601, and job 2 will be 223. Likewise it is processed based on our given job. If I am giving job 2, means it is dynamically create only 2 jobs corresponding to the cost. Also the splitting value is same. So next graph is for workload. So workload for each job is displayed here with the bytes value. So next, so first data have, there is the first data have the workload of 5080. So third graph is the power consumption graph, which is given here kilowatts. So the job 3 have high power consumption than other 4 jobs. Thank you for watching.